Good morning, students. Today we are going to discuss rotational motion chapter. Actually, our chapter name is System of Particles and Rotational Motion that is running at present. In that, previously we discussed about the center of mass. At, pre- at present, I am going to start the rotational motion. Is my voice and video, right? Letters. Is it appearing clearly? If anyone can write in the chat box. Okay, picture and voice. Is it appearing clearly? Okay, if it is appears clearly, then I will start the class. And you suggest your friends to come to the class because the continuity is very important in the physics. That will be useful for the 12th class. If you not have the foundation in the 11th class, then you cannot construct a building in the 12th class. Okay, it is not at all possible. Whatever that things we are learning in the 11th class, that is the most important for the 12th. Okay, I am not going to waste much time, and now I am going to start the class. Okay, anyone can write, is it clear? Voice and board, writing chat box, clear or not? Okay, thank you, baby mato. Right, for the reply. Now it is clear, I am going to start. Good. Right. Angular displacement. What is angular displacement? Actually, our topic is the rotational motion. Rotational motion is our topic. My topic is the rotational motion. In the rotational motion, what I am going to explain? Okay. In the rotational motion, I am going to explain the first some basic terms that are the displacement, velocity, acceleration. Actually, in the previously in the motion in straight line chapter, motion in a straight line chapter, motion in a straight line chapter, what we discussed. This is the previous chapter. Okay, in this we know the object is moving along a straight line. This straight line motion is called as the linear motion. In the linear motion, we discussed about the displacement term. Displacement. Okay, displacement means what? Shortest distance between the initial and final points. For example, this object starts at here and goes up to here, and the shortest distance between these two points, it starts from A and it goes to B. Then the shortest distance between the A and B is called as displacement. Okay, this is the displacement. Displacement means distance traveled. And later we discussed about the velocity. What is the velocity? Velocity is the rate of change of displacement. Okay, that means displacement by time. In 1 second, how much displacement it takes. That is called as velocity. Later, we discussed about the acceleration, right? Acceleration. Acceleration is the rate of change of velocity. That means, for example, if while going this object, if object velocity is changes, it has initial velocity u and final velocity v. Then acceleration we write as change in velocity by time. Okay, initial velocity u, final velocity v. Then the change in velocity is v minus u by time t. Okay, that is acceleration. Okay, now here these are the terms: displacement, velocity, acceleration, and in the laws of motion chapter we discussed about the force, right, and momentum. These are all terms that we discussed. These are all belongs to linear motion. That means when object moves in the straight line, these terms are used. These terms are used. In the linear motion, displacement we are using, simply we are telling that is a displacement, but it is a linear displacement. Velocity we are telling there is a displacement by time, it is a linear velocity. Acceleration we are telling that is a linear acceleration, there is a change in velocity by time. Okay, force we are telling F is equal to ma, that is a linear force. To move any object along a straight line, we should apply the force. And what is the momentum? Momentum is the product of mass and velocity. This is also called as the linear momentum. Linear displacement, linear velocity, linear acceleration, linear force, linear momentum. That means these all terms are used in the linear motion. What is linear motion? Straight line motion. If any object moves in the straight line, at the moment these terms we have to use. How much displacement it taken, how much velocity it is going, how much acceleration it is traveling, how much time it traveled, how much force applied on the object. These are all terms. Okay, these all terms are belongs to linear. This we previously discussed. Now I am going to explain the rotational motion. In the rotational motion also displacement will be there, right? Velocity will be there, acceleration is there, force will be there, but they have the different names. Okay, and their definitions and their formulas and their units we are going to discuss here. The displacement unit is meter, velocity unit is meter per second, and acceleration unit is meter per second square, force unit is newton, and momentum unit is mass into velocity. Mass unit is kg, velocity unit is meter per second. Now let us see here. First, angular displacement, which is said to be angular displacement. Angular displacement means what? Angular displacement is the angle swept by the angle swept by the radius vector at the center of circle is called as angular displacement. This is the definition of angular displacement. I will explain, you don't worry. This is the definition of angular displacement. Now I will draw the diagram for the angular displacement. This is a circle. Okay, you see very carefully, and if you will get any doubt, you can ask me. It is a circle, and you take one up. This is the center of the circle. Okay, you join the object. Okay, center and one object. There is some object here. Okay, this is the some object. That object is moving in the circle. Along the circle, it is going. Okay, this object velocity we can consider as v. It is going along this circle like this. Okay, the object is moving along this circle. For example, object starts at a. After some time the object goes to the point b. Okay, after some time object goes to the point b. At that moment, what is radius vector? Radius vector means, okay, you see here, you join the object, okay, and the center. This line, if you see the cursor also, okay, you see the cursor, the line is joining the red line, it is joining the object. This is an object which is moving along the circle like this, and this object and center, the line joining the object and center is said to be radius. It's a radius vector we can take. When object is at here, the radius vector is at here. Okay, and when object goes to this position, when object goes to the other position like this, see the cursor, right? And then where is the radius vector? Radius vector is the line joining the object and center. Then the radius vector will goes to this one, this position. This is the radius vector now. Okay, and now this angle, right? When object moves from a to b, when object moves from a to b, this radius vector is rotated by some angle. You see here, the radius vector is rotated from this line to this line. Radius vector position is changed, it rotated by some angle. That is the angle swept by the angle swept by the. You should follow the cursor also at the moment where what I am going to explain, that you understood, right? Angle swept by the, you see the definition, angle swept by the radius vector. This is the radius vector. Okay, in the figure the red line, radius is the radius vector, that will swept some angle in certain time. For example, in dt time, the object travel from a to b, right? It's angle swept by the radius vector is considered as d theta, or it may be denoted with theta also, right? For example, consider a body is moving along a circle Okay, along a circle of radius, along a circle in time small t, in time dt is a small amount of time. In time dt, okay, object moves from, object means here body. Okay, we took it as body. Body moves from where to where? From A to B. Okay. Then, in this case, the object is rotated by some angle. That is called as angular displacement. In this case, the angular displacement is from the figure. How much angle radius vector is rotated when object moves from A to B? You see the figure? OA is initial position of radius vector. OB is the final position of radius vector. From this line, when the object moves, this line also moves like this. Okay, this line also moves, and then this line is rotated by some angle. That angle is called as angular displacement. Angular displacement means how much angle object rotates, that's all. The radius vector, how much angle it rotates, that is called as angular displacement. Sometimes angular displacement may be denoted with theta, and sometimes d theta. Okay, right. We know that linear displacement, linear displacement is denoted with either ds or s. Yes or no? Okay. Next, continuation. This is angular displacement. Sometimes it may be denoted with theta or d theta also. Its unit is what? What is the SI unit? If you have any doubt while teaching, okay, SI unit of angular displacement. Angular displacement is nothing but how much angle it is rotated. That SI unit of angular displacement is radian. You remember it. What is the SI unit? Radian. Okay, can you know? Do you know how to convert the degrees into radians? Angular displacement means how much angle rotated. Generally, linear displacement means what? For example, in circular motion, linear displacement also you know. For example, object starts from A, okay, and goes like this, and and finally comes to diagonally opposite point. For example, like this it came. It starts from A and finally goes to the B. Okay, this is R radius. Object travel like this. Then what is the displacement and what is the distance? Can anyone write your answer in the chat box? What is the displacement and what is the distance in this case, in above case? Here displacement distance means it is a linear displacement. Previously we discussed linear displacement and linear distance. Okay, displacement means according to previous definition, according to the motion in straight line, this is the initial point where the body object starts. This is the final point where the body ends its journey. Okay, A is the initial point, B is the final point. You join the initial and final points with a straight line. That straight line length gives the displacement. This is the method to find out the displacement. Displacement means it is the shortest distance between the initial and final points. A is the initial point and B is the final point. Shortest distance between the A and B is this one, right? This is the shortest distance, that is called as the displacement. From the figure, the linear displacement is 2r. This is the linear displacement. Means length. This is a straight line length. What is the linear distance? Distance means what? Length of actual path. Actual path is what? Actually, the body is going like this. This actual path length is called as distance. This distance is also called as path length. It is equal to pi r, right? Half of the circumference of circle. What is the full circle length? Full circle length is 2 pi r, right? This is the full circle length. But here half circle only there A to B. A to B half circle only. That's why pi r is the distance. Is the distance is the displacement. In this case, if you want the angular displacement, what is the angular displacement? Can anyone answer? There is a lot of difference is there between the angular displacement and linear displacement. Angular displacement means we have to write how much angle it rotated. How much angle it rotated. How much angle it rotated? 180 degree. But we should not express in the degrees. We should express in the radians. Angular displacement is in radians because object is initially radius vector is at here and it rotates like this, and finally it comes to here. Initially object is at here A, and finally the object is at B. Initially the radius vector is this one, and finally the radius vector is this one, right? And now it is rotated by 180 degree. This angle through which object the radius vector rotates, that is called as angular displacement. Angular displacement is 180 degree. This you can also express in radians. 180 degree equal to how many radians? Do you know anyone? Anyone knows this? 180 degree is equal to pi radians. Remember it. Okay. Or 360 degree is equal to how many radians? 2 pi radians. But you must express in the radians. You must express in the radians. You can give the answer in the chat box. Anyone? Are you typing? One 180 degree equal to pi radians, 360 degree equal to 2 pi radians. This is how to convert into radians. Next one is I want to know one more definition. This is angular displacement. Angular displacement is nothing but how much angle it rotated. Next, angular velocity. What is angular velocity? Angular velocity is the omega. Angular velocity means rate of change of angular displacement. Okay. Actually, velocity definition is what? Velocity is the rate of change of displacement. This d by dt is called as rate of change of. D by dt means rate of change of. S is the displacement. Here angular velocity is the rate of change of rate of change of angular displacement. Rate of change of angular displacement. In the straight line velocity is there. In the rotational motion angular velocity is there. Rate of change of angular displacement is called as angular velocity. This is called as angular velocity. What is this? This is denoted with what? It is denoted with omega. It is denoted by okay omega. What is the formula for the omega? Angular velocity. You listen very carefully. Angular velocity is equal to omega is equal. There is a formula. What is it? Angular displacement by time. Angular displacement by time. Angular displacement d theta. Okay, by time. Okay, angular displacement by time. Angular displacement by time. This is the formula for the angular velocity. We write like this. Omega is equal to write as d theta by dt. What is the SI unit of the angular velocity? SI unit. Okay, that is the angular displacement by time. Angular displacement unit is what? Can anyone tell? What is the unit of the angular displacement? Angular displacement unit is what? By time. Time unit is what? Angular displacement unit you substitute here, and the time unit you substitute here. Then when you will substitute here, then you will get the angular velocity unit. That can anyone tell? Angular displacement unit is radian, by time unit is second. Radian per second is the unit of the angular velocity. Next, you take the screenshot now. Okay. If you have any doubt, you can write in the chat box. Even this lecture you can also watch later after the class also. because if any doubts are there, okay, once again also you can watch, because this is the live, it will be stored in the YouTube. Okay, and you don't neglect, you should come to the live class and watch in the live class only, because actually you may think that later we can watch, but it is not at all possible to watch in the latter. Okay, and if you will wait for 1 week, then 7 hours classes will be pending, then it will be makes problem for you. And now onwards every day class will be there. Okay, you take the care, because so much syllabus is there, even we not completed the 50%, that's why everyday class will be there in the live. Okay, right, you must support it. And now I am going to erase this total. It's not erasing. Okay, take care now. We are continuing the angular velocity. Angular velocity, we know that angular displacement by time, that is, for example, if time period, do you know the time period? For example, if time dt is equal to, if time dt is equal to time period. Okay, if time is the time period, what is time period, do you know? Okay, time period definition is what? If dt is time period, dt is equal to, if dt is equal to t, that is a time period, then time period means what? Do you know time period? What is the time displacement in the time period? Angular displacement, what happens? Okay, can anyone tell what is the angular displacement in the time period? Angular displacement, how much angle it rotated. Angular displacement become 2 pi, 2 pi radians. 2 pi means how many degrees? 360 degrees. Why like this? Okay, what I wrote here, if dt is equal to t, then implies d theta is equal to 2 pi you will get. Okay, then angular velocity formula is what? Angular velocity formula is, we know that d theta by dt, d theta by dt, d theta is 2 pi. Okay, t is capital T. Okay, this is the formula for the angular velocity. One more formula, what is actually time period? If you want to define the time period, we can write like this. Time period is what? Time period is the time taken to complete one rotation. Time period is the time taken to complete one rotation. Time required or time taken to complete complete one rotation. Okay, or the one revolution is called as time period, right? Time period is the time for one revolution, one rotation. Okay, time required to complete one rotation is called as time period. In one rotation, how much time it takes? In one rotation, time taken is the t. You see the cursor in the first line. In one rotation, the time is the time, capital T. But in one rotation, how much displacement it takes, how much angle it rotates. In one rotation, it starts from here and finally again comes to here only. That means it rotates by an angle 360 degree. 360 degree is nothing but, you should express the displacement in radians, 2 pi radians, right? 2 pi radians. Here we substituted. When the time is time period, angular displacement is equal to 2 pi. Then this we substituted in the equation. Then you got 2 pi by capital D. Okay, write in chat box if you will get the doubt in any step. And the frequency I want to know. What is the frequency? Frequency means what? Frequency is the frequency definition. You know frequency. It is generally denoted with nu. It is the number of rotations per second. In one rotation, how many rotations it completes? Number of rotations per second. Number of rotations per second is called as frequency. Is called as frequency. There is one that is frequency is nothing but total number of rotations by time. It is the formula for the frequency. That is equal to number of rotations by time we have to write. Number of rotations per second. Okay. Number of rotations per second. Number of rotations by time we have to write. This formula is frequency is equal to be write as n by t. Okay. We can write like this. And then by using this, we write like this. Um, we can also write if time is time period. Time is equal to time period. Then how many rotations it will take in the time period? Only one rotation, because time period is the time for one rotation. That's why when time is equal to capital T, number of rotations become one only. Then this we can substitute in above equation. Then we will write nu is equal to 1 by T also. That means reciprocal of time period is called as reciprocal means 1 by time period. 1 by time period. Reciprocal of time period is called as frequency. Okay, remember it. Reciprocal of time period. There is another definition for the frequency. Reciprocal of time period is called as frequency. Reciprocal of time period is called as frequency. Okay, right. Then frequency, if you want to write the formula for the angular velocity in terms of frequency. Okay, you know angular velocity formula. Okay, angular velocity formula is what? 2 pi. One formula is angular displacement by time. Next formula is 2 pi by capital T. But 1 by T we write as here nu. 2 pi nu also we write. Okay, these are the various formulas for the angular velocity. Okay, right. We can also write one more formula. If any object takes n rotations in time t. Okay, if object takes if object completes capital N rotations in time small t, then its angular velocity. What is its angular velocity? Can anyone tell? Then its angular velocity is what? Then its angular velocity. Can anyone tell? I want the answer from you. Angular velocity formula, angular displacement by time. Then angular displacement in rotations. How much angular displacement it takes? Time already dt is t. Then angular displacement is required. In one rotation, 2 pi angular displacement is there. In n rotations, how much angular displacement it takes? Can anyone tell? Yes, 2 pi n. In one rotation, angular displacement 2 pi. In n rotations, 360 degrees is the angular displacement in one rotation, but we should not express in degrees, radians required. 2 pi radians is the in one rotation. In n rotations, 2 pi n angular displacement by time we have to write t. Then the angular velocity, one more formula is 2 pi n by t. 2 pi n by t. Okay, take the screenshot and note it. Next, I am going to continue. I am going to erase these all things. I am trying to erase this site. Sometimes it is not works properly. Don't know why. Manual erasing is better. Okay, students, now I am going to continue. Till now, what we discussed. What is angular velocity? What is angular displacement? Okay, what is angular displacement? What is angular velocity? What are the various formulas for the angular velocity that we discussed? Next, angular acceleration. Next one is angular acceleration. What is angular acceleration? What is our topic? Angular acceleration. What is angular acceleration? It is denoted with alpha. Generally, acceleration is in the straight line motion A. Acceleration is the rate of change of velocity. That is the change in velocity by time. Okay. Its unit is meter per second square. Even in ninth class, you learned this formula. Now, in the rotational motion also, acceleration will be there. In the rotation here, when the a object will have the acceleration, if the velocity of object changes with the time, initially u, and after some time its velocity is v, that means the velocity is changing it here. Okay, then at the moment it has the acceleration. If it moves with the constant velocity, initial velocity, final velocity are equal, then acceleration will be zero because these two will cancel. That means if any object moves with the constant velocity, it does not have the acceleration. But in the circular motion, any object have, if the object have the acceleration, then what is the formula for the acceleration? Here we write the definition for the linear acceleration is the rate of change of velocity is called as acceleration. D by dt means rate of change of velocity. D by dt is the rate of change of t means velocity. It is called as acceleration. Now the definition of angular acceleration is the rate of change of the rate of change of angular velocity. Rate of change of angular velocity is called as rate of change of angular velocity is called as angular acceleration. Angular acceleration. It is denoted with the alpha. Then alpha is what? Rate of change of angular velocity. D by dt of angular velocity is the omega we have right. Yes, it is just like similar to acceleration. It is the rate of change of velocity. But here this is in the straight line motion. It's a linear acceleration, right? It is a linear acceleration. Straight line in the straight line motion acceleration. Right? Okay. Now the in the rotatory motion, the acceleration is called as angular acceleration. Its formula is d omega by dt. What is the SI unit of this angular acceleration? Omega unit is what? Omega unit we know previously. That is the displacement by time, angular displacement by time. It is the radian per second, radian per second by second. This unit is radian per second. by omega unit is radian per second, by time unit is second, radian per second square. Just like acceleration here unit is what? Meter per second square, and here radian per second square. That's all. Next, we write here, for example, when object velocity is changed from omega to omega naught. Okay, in time t, in time small t, if object velocity, angular velocity, okay, changes from omega naught to omega, then angular acceleration, how we write? Angular acceleration formula we write is change in velocity by time. Okay, this is the d omega by dt. D omega is the change in velocity, we write as omega minus omega naught by time is t. This is just like similar to the a is equal to v minus u by t formula. Okay, you know this a is equal to v minus u by t. Find velocity minus initial velocity by time is the acceleration. Final angular velocity, this is omega is the final angular velocity, omega naught is the initial angular velocity, t is the time. Now, what is omega naught here? Omega naught is the initial angular velocity. Initial angular velocity starting. Okay, angular velocity changes from omega naught to omega. Omega is what? Final angular velocity. Final angular velocity. Okay. Now, next, what is small t? Small t is the time. Okay, this is about linear. Oh, sorry, angular displacement, angular velocity, angular acceleration. Next, I am going to explain the important point, that is the relation between the linear velocity and angular velocity. Okay, important this one. Previously, 3 marks question came one time in the final exam. Okay, and the relation between linear velocity and angular velocity. Do you know what is linear velocity? What is linear velocity? Linear velocity means that we discussed in the previous chapters. This is a linear velocity. And one more, v is the linear velocity. What is angular velocity? Do you know this? You know this also. Angular velocity we discussed just now. I want the relation between these two. Okay. This is my question. They may ask in the exam that it derive the relation between the linear velocity and angular velocity. Then how we will go for this? And for this, you have to take a circle. You take it as a circle. Okay. And now, when object is moving along the circle, we can consider the object started at a at a time t is equal to 0 seconds. Then after some time, the object goes to the point B. It takes some displacement. Okay, initial position is this one from center to object A. A is the initial position and B is the final position. Okay, OB is the final position. Object travel from A to B with angular velocity omega. With angular velocity omega, it takes some displacement. Displacement means angular displacement, that is d theta. We can consider. And now I want this radius we can consider as r. Radius is r. And what is the linear displacement? How to get the linear displacement? Angular displacement is just by joining the uh, a angular displacement is the angle through which it is rotated. How much angle it is rotated? That is d theta. But linear displacement is what? Linear displacement means you have to join the initial and final points with a straight line. You see here. I'm going to join. Initial point is A. C. Initial point is A. Initial point is A. Final point is B. Join them with a straight line. This straight line length gives the displacement. This displacement we can take as ds in time dt. Okay, right. Okay, it was very simple and to understand here. in time dt. Okay, object moves from A to B along the circle, along the circle of radius small r. Okay, with angular velocity omega. Then it takes some displacement at here. In this case, what is angular displacement from the figure? Angular displacement is what? Angular displacement from the figure is d theta, right? And now I'm going to erase the left side. I want to derive the relation between the linear velocity and angular velocity. You watch regularly and see the continuity and where I am rubbing and eraser is not working properly actually. Or right. I did lot of hard work to erase this. Chalo, let us continue. Now see here. What is this continuation? Now from figure we write like this. From figure there is a mathematics formula is there. That is angle is equal to, for small values we write this formula, angle is equal to length of arc by radius. Angle is equal to length of arc by radius. How much angle it is rotating? D theta at here. Okay, see the figure. This is the angle, and arc is AB. AB. AB is the arc. But arc length nearly equal to this displacement straight line length. Okay, and then we take length of arc as ds. Actually, it is AB. Okay, actually it is AB, but AB nearly equal to ds from the figure you see. Okay, ds by radius we write as r. From this we will get the ds is equal to r d theta. And now what we have to do? Differentiate with respect to time on both sides, or otherwise divide with time on both sides. Divide with dt on both sides. Dt is the time. When you divide with dt, then what you will get? Okay, ds by dt you will get on the left side. On the right side, you will get is r into d theta by dt. You will get. What is ds by dt? It is a v is equal to d theta by dt is what? Omega. Then this is the relation between the linear velocity and angular velocity. Okay. This we can also write in the vector form. Linear velocity is the v, angular velocity is omega. Relation between the linear velocity and angular velocity is okay. V is equal to r omega. In vector form, we can write it as v bar is equal to omega bar cross r bar. We can write. Okay, this is the relation between the linear velocity and angular velocity. And next, one more point I am going to explain later. I will close today's lecture. There is a relation between the linear acceleration and angular acceleration. What is the relation between the linear acceleration and angular acceleration. What is the relation between the? I'm going to erase the total, and then after that I will start. Okay. If you have any doubt, you can write in the sentence form. I will explain. Arey, what? The erasing is the problem for me. Okay, more 10 minutes. I will continue the class. You listen very carefully. What is it? Relation between. One thing I want to tell that on the same day you have to write the notes and send the notes to me. And don't waste the time. Okay. On the same day you have to send the notes. Let us start. That is a relation between. Why it is not? Next one is the relation between linear acceleration and angular acceleration. Relation between the linear velocity and angular velocity we discussed. Next, linear acceleration. Linear acceleration means linear means a straight line. In the straight line, acceleration is a. Linear acceleration is a. Relation between the linear acceleration and angular acceleration. Angular acceleration. What is angular acceleration? That is alpha. I want the relation between these two. Then for the purpose, what we have to do it here. Let us see here. Very simple. This one, right? We have to use the relation between the linear velocity and angular velocity here. We know, right? We know the relation between the linear velocity and angular velocity. Just now we discussed. Yes or no? We know the relation between the. We know the between between linear velocity and angular velocity. Yes. What is the relation between the linear velocity and angular velocity? Linear velocity is v and angular velocity is omega. What is it? V is equal to, we know as r omega, right? Now differentiate with respect to time on both sides. Differentiate with respect to time on both sides. How to differentiate? Differentiate means you should apply the d by dt on both sides. You apply the d by dt on the left side, apply the d by dt on the right side. That's all. Applying d by dt is said to be differentiation. With respect to time, we are telling that's well by time we have to write. D by dt is the differentiation. In this dv by dt is what rate of change of velocity, that is the acceleration, linear acceleration. Here r is a constant, we have to write outside, then we write d omega by dt. D omega by dt is what? D omega by dt is the rate of change of angular velocity. It is called as angular acceleration. This is the relation between linear acceleration and angular acceleration. That is A is equal to R alpha. That is the linear acceleration is equal to radius into angular acceleration. That's all. Okay. Very simple. That is in vector form. In vector form, we can write like this. That is A bar is equal to alpha bar cross R bar. We can write. This is in vector form. How to write? Okay, right. Till now, what we discussed is something specially we discussed about the rotational motion, right? Some terms is we discussed. I will give one conclusion for that what we discussed today. Okay, and one table I will give it here for you. This is the linear motion. Okay, linear motion. Linear motion means a straight line motion. Okay, and this is the rotational motion. In the rotational motion, right? Some formulas we discussed, we derived. Okay, some terms are changing in the linear and angular. And the first term is that, okay, velocity we wrote. Velocity is the rate of change of displacement. Okay, sometimes we may write it v is equal to s by t also. Okay, velocity is equal to displacement by time also we can write. This formula will be changed in the rotational motion like this. Velocity become angular velocity. Whereas the displacement is the angular displacement by time it will become. Its unit is meter per second at here. Its unit is radian per second we got here. And next acceleration formula we derived. Right, acceleration is the rate of change of velocity. Okay, here its unit is meter per second square bit. Right, that you know already. And here in this second point, angular acceleration here. That is the rate of change of angular velocity. Okay, that is the radian per second square. What is this here? Displacement replaced with the angular displacement. S is replaced with theta. Velocity V replaced with angular velocity omega. Acceleration A replaced with angular acceleration omega. Alpha. Velocity V replaced with omega. That's all. Okay. Right. And we also discussed some relations. Right. Mm, acceleration, one more formula I wrote V minus U by T. Right. Here we write the acceleration formula, angular acceleration formula, omega minus omega naught by T. Okay. Like this, these three formulas we derived. Okay. And the next later we derived the relation between them. What is the relation? Oh, it is a short notes simplified. Okay. Whatever that we discussed it till now. Okay. Relation between the V and omega. What is the relation between V and omega? V is equal to R omega. And relation between A and alpha. What is the relation between A and alpha? A and alpha is A is equal to R alpha. Right? Okay. This we derived. And this is about today's class. And if you have any doubt, you can ask me. Okay. Otherwise, we will close today topic. Can I close? No doubts?